Hello everybody. So we're going to see how to replicate the table B8 that we have in the appendix that contains the enthalpies of different materials or different gases at different temperatures, which is this table. So I told you last video that this table is produced by doing the integration from the reference temperature, which is 25 degrees Celsius, to the temperature that we have here, which is simply the integration of CPDT from T to T reference. This is what I'm going to do here. So I'll zoom in now just to get a closer look at the calculations that we're going to do, and we already have the air already here. I put the table here just to easily compare what we are calculating to what we have in the table. The way I arranged this file is by putting the compounds here or the gases here, and for each gas I extracted the values of A, B, C, and D, so I already have them all here. And these are the temperatures, the same way they are put here, the same values, and this is where I'm going to do the calculations of the enthalpies. So simply we know the equation is the integration of CPDT, which is going to be A multiplied by T minus T reference plus B over 2 multiplied by T power 2 minus T reference power 2 plus C over 3 plus multiplied by T power 3 minus T reference power 3 plus D. I think I did something wrong. This is B5 over 3. There is a missing bracket here, and there was a missing bracket here as well. So the way I knew it is because this didn't have any color. It was in black. So if it's in black, then there's something not right here. Plus D over 4 multiplied by T power 4 minus T reference power 4, and this is the value that we have here. So if you compare this negative 0.72 and this is negative 0.72, so we have the same number. What I want to do now is to use this formula or write the formula in a form that will allow me to drag it without recalculating or moving the cells. The problem here is that if I drag it here, then these are fine, A, B, C, and D are fine, but it's using this cell as the temperature, and it's using this as the T reference. And if I drag it one cell to the bottom, it's dragging also all these cells to the bottom. So I want to make sure that all the cells will be calculated from the right cells, even if I'm moving or dragging the formula to the right or to the bottom. So one thing which is going to be very straightforward is the T reference. T reference must be the same no matter if I go to the right or to the bottom. So I'll press F4 for all the B.8s, which are the reference temperatures. So now this is done. So if I move to the bottom, T reference is still the same value. Of course the rest are not the same, but for T reference it's done. I want to make sure that when I move or drag to the bottom, that these cells are not going to move to the bottom. So the rows 3, 4, 5, and 6 must be kept constant, but they move to the right. And if I go to oxygen, it's going to pick the values for oxygen. So for the cells B3, 4, 5, and 6, I want to make sure that the numbers are frozen. So I can put a $sign before the number, and this way I can make sure that the rows are kept constant. So if I move to the bottom, it's calculated from these 4 cells. So if you compare the results now for these numbers to these numbers that we have here, they're exactly the same. So next to 0.72, 0.0 to 0.19, 5.15, 8.17, 11.2, they're exactly the same numbers. So if I drag till the end for 1500, it's 48.45. So it's perfect now. I'm done with this part. But if I move to the right, something is not going to be correct because these are okay, but the temperature is not okay. So I want to do the opposite for the temperature. I want the temperature to be kept constant if I move to the right, but I want it to change if I want to move to the left. For the temperatures, which are column A, starting A11, I want the A to be kept constant. So I'm putting a $sign before the letter, which I want to keep constant without, or keep the same. So now if I move to the right, let's say I'll check this. If I check this temperature is the same, this reference temperature is the same, the constants are in the same row. So I'm done. I'm now I have a table that I produced by myself that contains the same values that I have here. So let's pick any random value. For hydrogen, let's say hydrogen at 800 degrees Celsius, it's 22.85. This is hydrogen. For 800, it's 22.85. So if you check any number here, it's going to be exactly the same, no matter what is the temperature, what is the thing. There might be slight differences. For example, here for water at 1500, it is 61.09. It is 61.1, which is almost the same. It's not considered some big difference. It's not a big deal. So it's going to be a difference in approximation for the second decimal place, which is not a big deal. So this is one nice thing about this table, that we said before, that you can pick the numbers without doing any calculations. You just pick the numbers from the table, as we did in the previous video. There is one other thing that is very, very nice here, which is that you can put any numbers that you want. And in this table, the table is only restricted to these materials and to these temperatures. So in the previous example, in the previous video, we had to do interpolation to pick a number between any two numbers. But here, let's say if I want to go, let's say starting from 50 to 100, and I'm going to go with an increment of 50s. So now you can take these two and drag it. Now you have the values 50, 100, 150, and you can go all the way to whatever the value that you want. Okay, if you want to make it an increment of 25, then you can simply do the same. Of course, the table will be much bigger to cover the same range of temperature. But you see, I reached like way more larger temperatures than what I was planning for. So this is up to 2600s, and you have all the numbers with an increment of 25. You can make it increments of 5s, of 10s, of 100s. It's up to you. So this is one very, very nice thing here, that you wrote the formula once, and using this one formula that you wrote it in a proper way, you can calculate all these enthalpies, and you don't need to worry about anything later. You can create your own table that you can put in the appendix and use it as the constants or the enthalpies, instead of doing the calculations manually. And also here, one thing that I added to the table is I added two more gases. You can add as many columns as you want. You just add the constants, drag the formula, and you're done. So it's very, very, very helpful thing that you can do instead of doing the calculations manually. So I think that's all, and I hope it helps, and I'll see you next video, inshallah. Goodbye.